Hello friends, myself Manoj Rai. Today I'll go to discuss about glycolysis. Now, the glycolysis is one of the most important and typical phase of respiration. So this is quite tough, but let me make it quite easier. Okay. So what is glycolysis? Now, the glycolysis is means the formation of pyruvic acid. It is a pyruvic acid. How many? There will be two pyruvic acid. The two pyruvic acid from only one molecule of glucose. So this the conversion of one molecule of glucose to two molecule of pyruvic acid is called glycolysis, and which will produce how many ATP? We all know there will be 8 molecules of ATP. So this process mainly occurs in cytoplasm of a cell, not in mitochondria. Basically, mitochondria performs Krebs cycle and ETS. So the glycolysis is mainly occurs in cytoplasm, and it involves the formation of pyruvic acid from glucose, from one molecule glucose to two molecules of pyruvic acid. So what happens? The step one. In step one, you see there is one molecule of glucose which is 6 carbon compound. Now this 6 carbon compound uses the hexokinase enzyme as the ATP molecules breaks into ADP and phosphate, results the formation of glucose 6-phosphate. Now think the glucose is your kind of doctor. You want to become a doctor. So to become a doctor, you need some money, right? To go to MBBS college or whatever, requires some money. So cytoplasm, that means the parent, will give some money at the beginning of its journey, and in future our doctor, that is glucose, will give the feedback. So at the first few steps, we will see glucose is taking ATP, not giving ATP. So as it's giving ATP, the step is called phosphorylation because it has utilized ATP. The glucose utilized ATP. This is called phosphorylation. Very, very important in a competitive exam. That what is phosphorylation, why it occurs, when it occurs. So the first step, the glucose takes ATP to become glucose 6-phosphate. Okay, now in step 2, glucose 6-phosphate is ready to perform something, but the structure is quite odd. Odd means respect because it's aldehyde group. The glucose is aldehyde group, so glucose cannot undergo future steps in glycolysis. Glucose had to transform into fructose. Now fructose is a ketone group compound, so glucose changes into fructose by just transformation from aldehyde to ketone. Now this is called isomerization. So in step 2, the glucose 6-phosphate changes into fructose 6-phosphate. Now the fructose 6-phosphate is also a kind of master. Master means which respect? He is telling my bro, that is glucose, has taken ATP before, so I also want same ATP. So rather giving ATP, they're just taking ATP. This is quite interesting, no? So what they're taking, the glucose has taken ATP before in step 1. Now in step 3, fructose is also taking same kind of ATP. Now the fructose 6-phosphate will become fructose 1,6-diphosphate, as it has taken one more phosphate. So this is the step 3. So in step 1 and step 3 we have got ATP utilization states, means phosphorylation states. So already cytoplasm given 1 ATP, that is -1. In step 1 it already given 1 more ATP, -1. So ultimately we have got 2 minus. Now step 4. In step 4, the fructose 1,6-diphosphate, which is 6 carbon compound, breaks into 2 compounds, and both are of 3 carbon compound. The one is called PGAL, that is called phosphoglyceraldehyde triphosphate, and another one DHAP or dihydroxyacetone phosphate. Now both of these 3 carbon compound will produce each pyruvic acid. So eventually we will get 2 pyruvic acid. So from step 5 we will see only one cycle. That means either PGAL, either DHAP. Both will do same kind of activities. So in step 5, that is phosphoglyceraldehyde 3-phosphate, we can say this is PGAL. So this PGAL reduces NAD plus to NADH. Hence it has made 1,3-phosphoglycerate. We also can say PGT. So from PGAL we have made PGT and NADH. Now 1 NADH means 3 ATP. Now these are like ATM. That means we haven't got the money, but the message has been delivered. The salary has been delivered in our mobile through a message that you have got salary. So you have to go ATM machine for that to bring the money. So this NADH is like the ATM card, the ATM machine. This NADH has to go to ATM machine, no? To bank. So for NADH, the bank is ETS, the electron transport system. That will be our third phase of respiration. So in respiration, NADH will give us our desired 3 ATP. So we should count 3 ATP, that because it's giving ATP actually. Next is step 6. And in step 6, 1,3-phosphoglycerate adding ADP and phosphate to produce ATP. Now this step is called dephosphorylation, not phosphorylation, because in phosphorylation we required ATP, whereas in dephosphorylation we are giving ATP. As in this case we are able to see ATP, this is also called substrate level phosphorylation. In the previous case we cannot see ATP, but inside this NADH they have the capability to produce ATP in ETS. That's why this is called oxidative phosphorylation. So oxidative phosphorylation and substrate level phosphorylation both are not same, but both are dephosphorylation state. Both are dephosphorylation state. Okay. Now in step 7, 3-phosphoglycerate produces 2-phosphoglycerate. This step is not that important. This is the normal step in which they produces 2 PGT from 3 PGT. In next step, 2 PGT, that is 2-phosphoglycerate, just releases one water to produce PAP. This is called phosphoenol pyruvate. Eventually, the PAP, the phosphoenol pyruvate, uses pyruvate kinase to produce our desired pyruvic acid. By doing so, again they have produces one more ATP. As we have produced one more ATP, this is dephosphorylation state, and we can see ATP. So this is the substrate level phosphorylation. So in step 1 and step 2 we have utilized ATP, whereas step 5, step 6, step 9 we have produced ATP. Now we have multiplied with 2 because pGal will give one pyruvic acid and DHAP gives one pyruvic acid. Eventually we have produced 10 ATP, but we have used 2 ATP, so we have got 8 ATP. The complete reaction of this glycolysis involves the formation of 8 molecules of ATP. I hope the video is liked by you. Thank you.